Good. So now, if now, since everyone is on the same page, now let's move on to friction, right? Yeah, good. So friction क्या होता है भाई? Who wants to explain friction? Yes, Mashal.
We can say that the friction is a force that opposes a surface moving or trying to move over another. For example, if we are moving on a smoother surface, we
Mm-hmm.
would move for a specific time and we would move smoothly because there is less friction. But
Good.
when we try to slide over a wooden floor, we just stops after little time because of the more friction.
Good. Good. So anyone else who wants to answer the question? Raise your hand and answer. Anyone else? Okay. So I guess everyone believes that Mashal definition was more than enough to basically give, right? Okay, that's a good answer, right? So imagine, let me just give you importance of friction, right? Importance of friction, right? So imagine this is the ground, right? This is the ground over here. This is, let's say, the road, right? And let's say this is Hamza. Hamza walking it. Okay, and I'm going to draw Hamza's foot as follows, right? These are Hamza's foot. I don't think they would be so huge. Just imagine this. This is Hamza's Hamza's pair of foot, right? So as soon Hamza is walking in this direction, right? Hamza is walking in this direction. So now we're talking about, this is the road surface, right? This is the road surface which is made up of charcoal, which is pretty rough, right? And the greater the roughness, the greater the friction, right? So as soon as Hamza places his right foot and he basically applies a force in this direction, right? So his foot is applying a force in this direction, right? So friction क्या करता है? Friction basically applies an opposite force, right? Friction will be basically in this direction on his foot. This will be the friction on his foot. That's friction, right? So what happens? What is the benefit of this? Can you explain the benefit of this?
And sir, you don't slip.
Yeah, you don't slip, right? You don't slip, and your foot is basically stationary over here. Right? It does not move forward. Okay, so it's 0 meter per second. So in this case, हमारे पास the forward force है, that is equals to the friction force, that is the backward force. Therefore, if I want to find the resultant force using vector addition, जो हमने last class में हमने revise किया था, तो resultant force क्या होती है हमारे पास? It's just the direction wise vector addition, right? So plus F minus F friction, since they are same, this will come out to be 0, right? 0 newtons. That means your foot will be stationary, right? Okay, now imagine the same scenario but on ice, right? So this is on charcoal, or you can say tar road, right? इसको tar बोलते हैं हम लोग. It's the cheapest quality of charcoal which is used to make roads. Okay. Now let's imagine we had the following scenario. Okay, now we're trying to walk on ice. Okay, so this is Hamza again. Let me draw Hamza again. Now Hamza is, let's say we're talking about after 5 years. Hamza is grown now, right? So this is the foot which is exactly the same as it was, right? So this is the foot of, let's say, Hamza, right? And Hamza is enjoying the walk, right? Imagine he has no skates, right? He has no skates, no ice skates. He's just walking barefoot, right? Or let's say wearing shoes, right? The shoes which he was wearing on the road, right? Now he applies again a force F in this direction because that basically step forward, right? But okay, what is the scenario in case of ice? We have no friction on ice, right? No friction on ice. So now what would happen? So this component will be basically जो हम बोल रहे हैं F friction is equals to 0. It's not here. It's not available on ice. So what would happen to Hamza now? Anyone? So let's find out.
Hamza
And sir,
will
you
slide
must,
past guys.
Yeah, he will slip away, right? So if I want to find the resultant force, that would not be zero. That would be plus F minus zero. So you will have a resultant force of F on your foot, right? If you have a resultant force on your foot, therefore your foot will accelerate, right? That is equals to ma. Okay, and the acceleration of your foot will be F upon m, right? So he would slip by an acceleration of a, right? And he should have also some expressions also. Ouch, right? Would fell down. So this is the importance of friction. So friction is important, right? Imagine you're eating, right, and you're holding a spoon or a tea or a fork, right? Let's imagine you're holding glass to drink up some water, right? If there would be no friction, you would not be able to hold them up. How would you eat, right? So friction is also useful, but most of the time it's not useful, right? So imagine friction in your engine, right? So imagine your car is burning up, right? So let me just this was useful, right? Useful example. Now let's talk about the point, the place where it is not useful, right? Where it is not useful. Okay, that is in the engine of the car, right? So when the car is burning up the fuel and the car components are moving, right? So this is, let's say, engine. Imagine you're basically using a petrol, right, or any source of energy. Let's say battery if it is an electric vehicle. Imagine you're giving in 100 joules of energy, right, using a petrol, any power source, and your engine is giving you only 21 joules as an output, right? So if you want to find the losses, so how many energy is lost? That is 100 minus 21. So you lost approximately 79 joules of energy in friction, right? So over here, it is not useful, right? Because you want your engine to be giving you almost closer value to the input energy as the output, right? So here it is not useful, but it basically in space. If you go to space, you won't have any friction, right? There is no air. Air रेजिस्टेंस नहीं होगी हमारे पास, ठीक है? So drag जो होती है हमारे पास, let's say if you are paragliding, ठीक है? Let's imagine if you're paragliding using a balloon, hot air balloon, right? And if you're paragliding like this, so you also basically face an opposing force that is called air resistance, right? So this is also one of the example of opposing forces. ठीक है? So friction is the force that opposes one surface moving or trying to move over another. It can be a help or hindrance, right? We have seen both the examples right now. You cannot walk if there was no friction, right? We have seen that our feet would slip away, ठीक है, when we tend to walk on ice. On the other hand, engineers try to reduce friction to minimum in the moving parts of machinery by using lubricating oils or ball bearing, right? Like, as I told you over here. So this was the output energy. This was the output of the engine. That was only 21 joules. Okay? And this was the energy which we supplied to the car, right? As a form of petrol or battery in form of electric vehicles, right? So we want these are the basically two dimensions of friction. One is useful, one is not useful, right? अच्छा जी. So if I want to just define friction in a definition, single definition, that would be as follows, right? What is friction? Friction. So you would define this friction definition as follows. So it is an opposing force which occurs when two objects are moving on one another, right? ठीक है जी. So let me just give you an example. Just see this tire, right? This is a tire over here. Let me just draw a contact also. Okay, good tire. This is your tire over here, right? Let's imagine this is your tire, and your tire is basically trying to move. Okay, it's applying a force in this direction. Okay, it's applying a force in this direction, right? So the friction would be where? Where would be the friction acting? Yes, where will the friction acting over here? It will be acting over here, right? in opposite direction, right? Make sense? To basically so that your tire does not slip away, right? Just imagine when it is winters and you're trying to basically make your basically hands warm or your body warm, right? So you rub your two hands against each other, right? You can rub your two hands against each other right now. You will feel that it is getting warmer, right? So the friction produces heat energy, right? And heat energy is also useful, okay, in winters, but in engine, in your cars, it is not desirable, right? If it makes sense, what is friction and the definition makes sense, the example makes sense. Give me a thumbs up. It makes sense to Ryan, Mashal, Ruba, Varda, Azan. Okay, not to Maeve. Maeve, what is unclear?
I didn't get the example that you explained.
Which example? This one?
The friction one. No, the other one.
This one?
Yeah, that one.
Okay, so it's pretty simple, right? Just stand up and start to walk. Maeve, just stand up and just put your feet again. Okay, just put your feet up in this direction. You would basically your feet will provide a force in this direction, right? Imagine if you're
Yeah.
standing on your room with this carpet, or let's say there's some marble over there, some flooring. There would be a friction force which will basically stop your feet. Just try to walk. You will see that. Okay. So this is friction force. Okay. So it's acting in opposite direction. You're applying a force in this direction. Your feet is applying a force in this direction, but your floor is applying a force in this direction, right? So this basically helps you to walk. Let's imagine if you're holding a tablet or a pencil on your hand, in your hand, right? So your hands, your fingertips are able to hold a pen, right? How? Because friction, right? There's a friction between your fingertips and the pen, which is basically keeping it together. Does that make sense?
Yeah.
Does that make sense, Maeve?
Yeah, it does.
And if you let's imagine if you walk on ice where there is no friction, so you would obviously slip, right? So slip कैसे होगे? So this is basically the mathematics of that. Not the mathematics. This is the equation wise. You can say proof that you would accelerate by acceleration of force over mass, right? That is the force that was applied by your foot, and you would slip away in this direction, right? And you fell down, right? So that is the importance of friction. Make sense, Maeve?
Yeah, I got it.
Give me a thumbs up if it makes sense. Because आपके your voice is not so clear. Okay, good. ठीक है. So now we have some discussion over here, right? So let's discuss it out.
Yes, sir.
Okay, so now we're gonna talk about some types of friction, and which are available on road surface, on liquid surface, and on air surface, right? So any opposing force which tries to stop the motion is basically called friction, right? So let's just see this picture over here, and let me just first of all insert a blank slide over here, and let's copy this figure over here. Okay. G. So let's see this example over here, right? So this is an experiment which basically measures the force friction, right? So this is a spring balance. So what is a spring balance? And let me just explain the setup. So this comes in your MCQ, right? It's pretty much okay. Let me just save it first. And now just see this. This is a spring balance which is attached to a block of mass, let's say capital M, right? So and P is the forward force which is applied by your hand, okay? And F is the friction force that is basically available between the table and the box, right? It is a friction force between the table and the block, right? So this spring balance basically it measures it measures the P, right? So how much force are you applying, right? It measures the P. You can see the readings over here. It is measuring the reading, right? It measures basically P in newtons, right? So let's say it was stationary initially and this spring balance is basically not attached. Let's say it is starting from 0 newtons. हमने कोई force initially लगाई नहीं है, ठीक है. Then we start to apply the force, ठीक है, slowly, right? Let's say we make it first, let's say 5 newtons, right? And we saw okay the block is still not moving. Now we basically made it to let's say 8 newtons, right? So we are measuring the force from here. We are seeing the force from here, right? This is our eye over here, and we're trying to see okay, what force are we applying, right? So now the force is 8 newtons, and at this particular point, the block starts to move. Okay, so you can just say okay, the friction force is basically equals to 8 newtons, right? Why? Because when the P became greater than 8 newtons, let's say it was let's say it was now roughly around 8.1, right? 8.1 पे it started to move. Let me rub this. And around 8.1 newtons, it started to move. So I can say okay, the forward force should be greater than 8 newtons for the motion to start. Does that make sense? For the motion to start, right? So this experiment can be used to measure the friction between the table and the block, right? So now keeping this in mind, let's read what is provided in the slides over here. Let me just quickly save it. Okay. So now again, it is just saying if P value is further increased than the value of the friction, it starts to move, right? So F has its maximum value that is called static friction, right? So static friction क्या होता है? This is a friction which basically needs to be overcome for the motion to start, right? Then you have dynamic friction, right? So what is dynamic friction? Dynamic friction is basically the friction which is occurring during the motion, right? So yeah, so you have two types of friction, that is static friction, and then you have dynamic friction, right? Right. So static friction is basically needs to be overcome to start the motion, right? And dynamic friction is the friction that is basically occurring on the block during motion, right? Okay. Now, friction drag. What is drag? Basically, it's act on an object or a vehicle which is moving through air, right? So that is called air resistance. Imagine the car is moving, right? The car is moving across the road over here, right? So it is applying a force F by the engine. The engine is applying a force of F newtons to basically keep it moving. There would be a constant opposing force to the car that would be air resistance, right? So this air resistance is also family of friction, because what is friction? It just opposes the motion, right? Okay. Similarly, friction drag, right? So drag is a force that acts in liquid, right? So imagine you're swimming, right? Imagine you're swimming over in a, let's say in a pool, right? Let's say you're swimming over here, right? So if you're applying a force in this direction to move forward, okay, there will be constant drag to your motion, right? That will be basically be trying to stop you down, right? So friction is available in air and in also liquids, right? So drag increases as the speed of the object increases and acts to reduce the acceleration and objects to basically slow down, right? Similarly, drag, air, resistance, friction, they all are opposing forces which tries to basically stop the motion, right? So this is the friction which needs to be pretty clear to you guys before moving on. If it is clear till now, kindly give me a thumbs up and talk about some types of braking distances and end the lesson, right? If it is clear till now, please give me a thumbs up. Clear to Mashal, Azan, Ryan, Rupa, Hamza. Okay, maybe I guess you joined 10 minutes later, so you can rewatch the recording. Okay. Okay.
Yeah.
Huh. So you want to talk about this these type of distances over here when you apply a brake, right? Imagine. Let me just draw the scenario for you guys. So you have the following scenario. Okay, you have the following scenario. So you have the road, right? And you see a bump. Okay, you see a bump over here. And this is the car that is basically being driven by you guys. not a hat, it's a car, right? So imagine you're driving the car and you're sitting over here on the steering wheel, right? Okay. And you see this particular bump over here, right? Now, after as you see the bump, okay, that is position A and this is point B, right? So after just seeing the bump, okay, seeing the bump on the road, till basically slowing down over here, okay, you have basically these three distances over here. So you first of all think, okay, so what is the procedure for basically this entire process? You first of all think, so basically we have thinking distance, and you basically do what? You apply the brakes. Okay. So if you combine the step 1 and 2, you get the overall stopping distance, right? So just imagine that you're just seeing the speed breaker over here. So this is a speed breaker. You just saw it. Your brain basically makes decisions, right? And you calculate, okay, should I apply the brakes right now or not, right? So this is thinking distance is basically the distance traveled during your basically you're making a decision. Should I apply the brakes or not? It's a human reaction time, right? This is also called as human reaction time. Okay, how much time you basically take to make the decision, right? It basically varies from people to people. Imagine for a young person, right? It's small for a young person. Okay, it is relatively small, right? It's smaller, lesser as compared to old person, right? Because old person has, let's say, he has weaker memory, right? And he is basically weaker decision time, so it can vary from people to people, right? Then you press the brakes, right? So after pressing the brakes, it's between the car and the road, right? Then you have basically after applying the brakes. Okay, now you have applied the brakes. So now the destiny basically remains basically depends upon your vehicle and the road, right? So it is the distance traveled over the road after the brakes have been applied, right? And the car has been brought to rest, right? And if you basically want to combine these processes, process number 1 and 2 together, you get stopping distance, right? So it is a distance traveled that is actually taken to stop a car. Okay, that includes the thinking process and the braking process, right? So you have stopping distance, which is as follows. So stopping distance equals to what? It equals to thinking distance, TD, plus braking distance, BD, right? So if you want to just see an example over here, this is an example over here, right? So you have this thinking distance, right, on different speeds. Okay, let's say your car is driving at 30 kilometer per hour speed. So your thinking distance basically goes to 6, right? So these are basically values for a single, let's say, experiment. We have chosen a person who's done an experiment here and got these results, right? And this is the braking distance over here at different speeds, and this is the total stopping distance, right? Let's analyze this particular part, right? So we have this following equation. Okay, stopping distance is basically what? It is the thinking distance plus the braking distance. So you are given what is, so we're talking about at speed equals to 90 kilometer per hour, right? So what is the scenario over here? You have stopping distance equals to the thinking distance for the person that was used in the experiment is 18 meters, right? And the braking distance which the car traveled after applying the brakes was 54 meters till it stopped. Therefore, the total distance which basically the process took is as follows. That is 54 plus 18, that is 64 plus 8, that is 72, right? It took 72 meters to basically add a speed of 90 meter per second to bring the car to 0 meter per second.